Greetings to you. My name is Dr. Aligamhe Victor Imonike, and I will be presenting a paper titled Risk-Based Predictive Modeling for Highway Project Duration in Nigeria using Multiple Linear Regression and Artificial Neural Network. This paper is co-authored by Dr. Muzani Mustafa and Dr. Ido Ayobami. Timeline delay, scope modification, inadequate contingency, and inflation has been identified as recurrent barriers impacting project success. Conventional estimating approach do not give adequate priority to risk during project planning and implementation. Schedule risk frequently affects the completion of construction projects significantly. There is need, therefore, for an efficient and accurate tool for estimating highway project duration based on historic data. There is little or no evidence in literature of the use of artificial neural network in developing scheduled predictive models for highway projects in Nigeria. Hence, this study is conducted. The aim of this study is to develop predictive models for highway projects based on artificial neural network and multiple linear regression techniques with a view to comparing both models in terms of accuracy in predicting actual duration of construction projects. The specific objective of the study, therefore, is to identify schedule risk factors that severely impact highway projects, in other words, critical schedule risk factors. And secondly, to develop artificial neural network and multiple linear regression models for forecasting future highway project duration. The research methodology used in this study commenced with literature review in order to identify, in general, risk factors impacting highway projects. This led to the identification of 154 risk factors. In order to streamline this, the specific need for the study, focus group discussion was conducted, leading to the identification of 85 schedule or time risk factors. These factors form the construct with which the questionnaires was developed. In order to ascertain the time performance of projects, having identified 103 highway projects, a pro forma was designed to determine the cost overrun, or rather the time overrun on this project. On the other hand, the questionnaires was used to identify or to examine the risk that was inherent in this project in terms of their severity as well as uh, occurrence. To analyze this data collected, this study adopted the mean score, Pareto rule, as well as the multiple linear regression and the artificial neural network. The mean score was used in order to rank these risk factors identified in terms of severity, and the formula is stated on the slide. Whereas the Pareto rule was deployed in order to identify the top 20% of this risk factor based on the ranking. This then led to the identification of 17 critical schedule risk factors, and this formed the independent variables for the model development. The historical data, which is the dependent variable for the study, was partitioned into 80 to 20%, being that 80% of the 103 projects were used as training, while the other 20 for testing or for validation. Multiple linear regression were then computed, as well as the artificial neural network was then also used in order to determine the accuracy of prediction. Now, in order to determine the level of accuracy, the mean absolute error was used, as well as the uh, MSC, mean square error, and the RMSC, the root mean square error. The top or critical schedule factors identified in the study, some on the as identified include the delay in payment by client, which topped the critical risk factor, non-availability of spare parts for construction equipment, non-availability of desired plants and equipment, unavailability of special equipment, shortage of construction material, and the list on the critical factors, which are the 17 critical factors, is change in design. However, you can identify here that the client plays a major role in project completion. Hence, delay in payment could impact greatly project performance in terms of time. And also, we could also identify here that machine plays a very critical role in highway project execution. Hence, must be given the needed priority. The results from these models shows that the multiple linear regression deviates significantly from the observed data, which is the actual time performance of this highway project that was used in this study. Whereas that of the artificial neural network pattern closely to the observed data. So as you can see on the table on your screen, you can observe that the test data, the test project, or which is 20, which are 20, you can see that the points as shown in the graph, the artificial neural network pattern closely as compared to the multiple linear regression. Furthermore, the MEP, which is the mean absolute percentage error for the ANN, is 12.065%, indicating that the artificial neural network model has a performance of 87.95%, whereas that of the multiple linear regression has an MEP, which is a mean absolute percentage error, of 15%, showing that the multiple linear regression predictive model has an accuracy of 85%. Furthermore, we could find out, or we could see from the table on the screen, that the artificial neural network sustained the entire 17 dependent variables, which are the risk factors identified or arrived at using the Pareto rules, whereas the multiple linear regression was only able to accommodate 10. This shows that the multiple linear regression do not have the ability to handle multiple data and hence also do not have the ability to handle multi-collinearity in terms of data. In conclusion, major causes of highway projects poor performance were identified as delay in payment by clients, equipment problems such as shortage of spare parts and shortage of equipment. The developed model, therefore, will be useful to the Nigerian highway project contractors in determining the actual duration of projects, giving a set risk parameter. Prompt payment for work properly executed is paramount to the timely completion of federal highway projects in Nigeria. The artificial neural network predictive models demonstrated superiority over the multiple linear regression models in terms of accuracy. The findings of this study, therefore, will guide researchers in exploring the application of artificial neural network in highway projects. Key implication of this study is that the model has the potential to improve decision making in project management. Future study, therefore, could be explored in terms of identifying more risk factors and using data from different types of projects. Lastly, highway experts should be involved in developing artificial neural network predictive model that will enhance project performance. Thank you for listening.